Hi guys, let's solve this question. And yeah, let's see. I think it's an excellence question again. So it says a parabola passes through the points minus k0, and 0 comma alpha, where k is a constant. The area between the curve and the x-axis is exactly 8 units square. Calculate the value of alpha in terms of k when alpha is greater than 0. So they have given us the information that it's a parabola, right? And it passes through these 3 points, right? So let's start with that. So we have a parabola. So let's plot. So if I have that as x-axis, let us suppose that is my point minus k0, right? That is my point k comma 0, right? So that means both these points are on x-axis because the y is 0. The third point they say is 0, so that means it should lie on the y-axis because it's 0 and it's at alpha, so it's at the positive point. All right, so it's here and that is 0 comma alpha. All right, so here if we join it together, we will be able to form a parabola. Right, so let us suppose this is our parabola. It's not that neat, but that's all right, it will do the job. So that's our parabola. Okay. Now we know that when we have the roots, right? So when roots are given, or we call it when the, what do we call? X-intercepts are given. There are multiple names for this. So when roots are given, I use the word roots. So when roots are given, the equation of a parabola is a constant. It could be a, b, c, whichever constant you want to put, comma x minus the first root. So if it is x minus of minus k, it's going to become x plus k, and x minus the other root, which is k. So this is a general equation when we know the roots or x-intercepts of a parabola. All right. We also know that this point here is going to be the vertex. All right. How we know that it's going to be the vertex? Because it is exactly in the middle of these two lines, right? So your vertex is always in the middle, all right? And it is, this line is exactly in the middle, right? It's axis of symmetry here. So when it's axis of symmetry, the point on the parabola on axis of symmetry is your vertex, all right? So in that case, what we can do is, if this whole equation, the equation that we just found, is passing through that point 0 comma alpha, we can convert this whole equation into alpha is equals to c. We don't know what c is. Bracket x this time is 0, so 0 plus k and 0 minus k. So this gives me my c, and then times k times minus k is going to give me minus c k square, right? And that is equals to alpha. So this gives us the value of c is equals to alpha over minus k square. All right. So now when we put this value back in there, there is nothing there that we don't know about, right? So there are all the equations that is given in the question. C was the only thing, capital C was the only thing we ourselves put in there. And that's why we are putting that value back in terms of all the variables that is given in the question. So now the equation becomes y is equals to alpha over k square, x plus k, and x minus k. Now we can simplify that by saying x minus k square is equals to, this whole thing can be written as x square minus k square, right? Remember, a plus b and a minus b is equals to a square minus b square. It's that identity I have used. All right, so now I have got the equation of the curve. All right, now what we have to do is we have to integrate to find the area, and they have given us that the area under the curve is 8 units. So when area of this whole thing between x-axis and the curve is 8 units, 8 units square, we have to find. So now we know that this is the axis of symmetry. The middle line is your axis of symmetry. This line here is your axis of symmetry. So this thing is exactly half of this thing, all right? So, or double. So what we have to do now is we are integrating from, I would do from 0 to k, just because it's easier when you have one of the limits as 0, you substitute, the calculations becomes easy, right? So the whole area is equals to twice of something that is from 0 to k, right? So we have alpha over minus k squared x squared minus k squared dx, right? I have done twice because I have divided the area into two parts, all right? This part and this part, so it's twice. Now, when we integrate, we will get alpha and minus k squared as it is because they're constants. 2x squared, when you integrate, is going to become x cubed over 3 minus k squared will remain k squared and x because we are integrating, right? 0 to k. So 2, let's bring all the constants out. Now here, when I substitute k, it's going to become k cubed over 3 minus, this is also going to become k cubed, because if I put k here, it's going to become k cubed, right? And then minus, when I substitute 0 in there, it's going to be 0 and 0, so that's 0, right? Now, let's simplify that. So in the area, we know that the area is 8. Let's put 8 there. Now we have 2 alpha over minus k squared times, if I solve this here, it's going to be over 1 times, no, nothing here, times 3 for these. So now this is going to be k cubed minus 3 is going to give us minus 2k cubed over 3. All right, I'm solving the fractions there. And that is equals to 8. So 8. So here 8 is equals to minus 4 alpha k cubed over minus 3k square. That cancels. K square will cancel this because there are 3 k's on the top and 2 in the denominator. Now when we solve this, we will be having, so we need to find, let's go back. We need to find the value of alpha in terms of k. So we need alpha is equals to something. So let's leave alpha here. So we have alpha is equals to 8 times 3, right, over 4k. So 4 times 2 is equals to, alpha is equals to, or let me write that way, 6 over k is equals to alpha, right? And that's what we had to find. Cool. That wasn't too bad. Have a good day.